Hello, thank you all for coming here today to hear us talk about our work this summer. So my name is Victoria, and along with Shen and Carolina and Alicia, we are the ORCA team. So we were able this summer we had the opportunity to look at ORCA data, ORCA transit data. So ORCA stands for One Regional Card for All. And as I'm sure you know, this is what an ORCA card looks like in a tapper. So it's basically the Puget Sound's version of an electronic fare payment card for public transit services. And it was introduced in 2009 with a bunch of features for users that they could directly benefit from. So it automatically calculates fares and transfers. It allows for you to transfer between transit agencies. And also it would improve the efficiency of actually boarding on a bus. Above and beyond these benefits, however, ORCA cards collect a lot of other information. So each ORCA card has an ORCA type. There are 5 different types, either an adult, a youth, senior, low income, or disabled. So we can learn a lot of information about what these different groups, how they're using the transit system, how that might differ from each other. In addition to that, we can also derive a bunch of interesting trip and transfer information due to the fact that each card has a specific user ID. And all of this information can really help transit agencies understand how the transit system is being used by ORCA users and where there might be deficiencies and what might be the best practices for improvement. However, as I mentioned earlier, while these cards were introduced in 2009, the data hasn't really been used yet. And a lot of that has to do with privacy concerns about the fact that each individual ORCA card has a user ID, and the ones that are subsidized by employers have a business ID as well. So in addition to having hashed user and business IDs, we spent the first couple of weeks of the summer with the help of our data scientists putting the data up in a secure database in the cloud so that we were able to do all of our data cleaning and exploratory analysis, knowing that the sensitive aspects of the data were safeguarded. And so one of the major products to come out of our work this summer has been from that exploratory analysis, and we've created a suite of applications in an integrated dashboard to help shed some light on sort of the richness of the data and the potentials for discovery therein. So this is a little bit of what our dashboard will look like that we will walk through in this talk. And I want to stress that each of these individual applications that we've created offer a lot of insight into what is available in these data, but we're really just scratching the surface of what can be done here. In essence, this project really reaches beyond purely just transportation or data science, and at a larger scale, we're forming the foundation of what can be termed a smart city approach to transit planning in the Puget Sound region. So with that, I'm going to hand it off to Shen, who's going to demo the first of our apps and give you a better sense of what is actually included in the ORCA data.
So, as Victoria just said, just based on ORCA data, we can already visualize a bunch of information about passenger ridership patterns and types of passengers that were not available before. So, this is one particular application out of the suite of 5 that we made this summer that just allows you to visualize the ORCA transactions data. So on the right-hand side, you can see the available selections. So you can input a particular route number and look at its passenger patterns based on direction, date range, and type of day. So here I'm gonna demo using the route 271, which is an express commuter bus route going from Issaquah via Bellevue to the University District. So you can see on weekdays, the x-axis here shows you the time of day, and then the y-axis shows you the raw passenger count. So on weekdays, you have 2 very dramatic peaks, one in the peak morning commuting hours, and the second one in the peak evening commuting hours. You can also zoom in here to show the other passenger types other than adult, because they might be hard to see at the previous scale. So here you can already see some interesting patterns with youth passenger type, for example. For that particular passenger type, the peak is a little bit earlier than the peak evening, so just after school lets out. And this route is also interesting because if you toggle to weekend, then you'll see a very different commuting pattern, right? So as I mentioned, this is a express commuter bus. So on the weekends, there's not the same dramatic peaks during the morning and the evenings, and the raw passenger count is also lower. So just with this very basic app you built solely on ORCA data, we can already visualize a bunch of information. But ORCA data is only a subset of the entire ridership, so not every passenger uses ORCA card. A lot of them still pay with cash. So I'm just going to talk through what other types of data we had in our initial database. So on the lower left-hand side, we have the ORCA transactions data. So these data are generated whenever a user taps on at the tap machine. We also have two other types of data available to us in the initial database. The first one, AVL, stands for automatic vehicle location, and these come from sensors placed on buses, and they tell us where the bus think it is at that particular point in time. We also have APC, which stands for automatic passenger count, and those are step sensors that are also placed on buses, and those sensors tell us at how many passengers get on and off the bus at each particular stop. So these three data types comprise our initial database, and now I'm going to pass it to Carolina to talk to you about how these databases work together.
So as we've seen from the initial demo, the ORCA data itself has a really high granularity, some really interesting patterns you can look at, but it actually only applies to a subset of the overall ridership around the Puget Sound region because, as Shen mentioned, a lot of people will still pay with cash or in other ways to get on and off the buses. So if we want to start doing further investigation from ORCA, it's really helpful to contextualize this rich data set with the broader estimates of passenger counts around the region, especially because at least for the King County Metro, we only actually have passenger counts for 30% of the buses overall. 70% of buses, we don't know how many people actually got on and off of them. So being able to understand the variation and the difference between ORCA and APC is very useful for future transit planning. So the dashboard demo I'm about to do for you is basically just a diagnostic tool to better understand the distribution of the differences between APC counts and ORCA passenger counts. So let me just quickly click back in. And our map is still where it's supposed to be, which is actually quite exciting if you've been around us all day today. So what you're looking at right here is a map of the Puget Sound region with census tracts colored according to the difference in passenger count boardings. So the darker blue colors mean a lot more passengers got on without paying cash, and the lighter green areas are where more passengers paid with ORCA, so you had more parity between ORCA and APC. And this is specifically showing the relative count, so what proportion of ridership, of total ridership in this census tract was paying with cash. So you can see some interesting patterns around the region where Tacoma, you see there's a much higher level of paying by cash or not using ORCA cards. We want to bear that in mind as we're doing our analysis. And even in some places like downtown Seattle, where you have really large ridership overall, if I just showed you the absolute counts, it would be dark everywhere. But you can see that even within downtown Seattle, there's variation in which parts of the city people are and are not paying in cash. So we wanted to be able to understand the context for ORCA so that we can provide guidance for working with it in the future. That comparison is really important to make, but it turned out that it was not a trivial one to make because while we have these nice two sets of information in our original database, they couldn't originally talk to each other. ORCA taps are ORCA taps in space and time on the ORCA system. Buses are buses in space and time on a bus system. And a bus might think it knows where it is, and an ORCA tap might think it knows where it is, but the two of them are not communicating with each other at all. So we actually spent much of the summer doing a lot of data cleaning, pulling in additional information, pulling in the GTFS transit information, which is the General Transit Feed Specification. It's what Google Maps and One Bus Away use for their routing information, to be able to identify when does a bus get back to the start of its route and keep going again, so that we could start to identify unique journeys, get ORCA taps onto the right journey, and eventually get matched counts of ORCA boardings and APC boardings for an individual stop in time. After that, we then had to also remove times when we thought the readers were broken. So sometimes the ORCA reader doesn't work, sometimes the APC reader doesn't work. Without going into a lot of boring detail, I'm just going to put this up and let you know this is one of the queries designed to find and remove bad data. that was 2 weeks of my life. I'm going to move on. Having got the data to a usable, not perfect, but a usable state, we could start to actually do some interesting analysis about 10 days ago. And so one of the first things that I've been really interested in, our project lead Mark is really interested in, is actually understanding that difference between APC and ORCA so we can hopefully integrate corrections into future transit planning based on ORCA. So I started, and this is very preliminary stages, so if people want to talk to me about ideas for how to continue with this work in the future, I'd be interested to hear, and I know Mark would too. But I started some basic analysis trying to do predicted boardings on the basis of ORCA TAP. So this was using random forest methods. I haven't tried any other machine learning methods. But I'm able to take, so these are two very different routes, the 44 going from Ballard to UW, and the 671, which is actually the rapid ride A line, which is going basically from Tukwila north in South Seattle. And you can see the patterns are, the shaded out dots are true, are stops where we have the true boardings. The solid ones are ones I've predicted, and you can see, predicting something that looks similar, not surprising using the original data. I can talk more about this afterwards if people are interested. But you can see the 44 tends to stay on that, perfect fit line between ORCA and APC, saying the 44 people tend to use, UPasses, ORCA cards on that. The rapid rides, people don't, which isn't surprising, because rapid rides you can tap when you're not even on the bus yet. So you're going to expect that boardings are a lot higher on a rapid ride than ORCA taps would suggest. And as we build these models, we also want to keep into account spatial features, demographic features, and also just information about the route. So these models were fit separately, and it's interesting just to start thinking about how some of the important features as we talk about predictions based on route vary between these. Again, I'm not going to spend too long on it, but you can see that some of the demographic variables are differently important. This is looking at basically how much the error in the model increases when you remove each of these features from the model. ORCA-ONs predict on 44, they don't predict as well on the rapid ride because not as many people are tapping. So again, really happy to talk with folks after for more ideas. I'm going to hand it over to talk about some of the more exciting analysis we've done.
Okay, so now that we have a basic understanding about what ORCA represents and its limitations, we are able to combine it with external supplemental data sources to do substantive analysis. And 3 of the data sets that we brought in for our app are the overloads data, the ACS social demographic information from the American Census, and also neighborhood information from the American Census. And next, I'm going to talk about the overloads or overcrowding data set that we brought in. So as overcrowding is defined as when a bus passes you by because it is too full. So it could be extremely frustrating if you have experienced it. I had to crop out her hand gestures to make it appropriate for this talk. So traditionally, overcrowding data comes in the form of text documents, which is a report from a driver when overcrowding first start to happen on a route. However, after combining APC data and ORCA data, we are able to start to figure out how many stops after the initial stop is overcrowding still a problem. And we put that on an interactive map in our dashboard. So let's talk to overloaded buses and move it a little bit. Oh, okay, thanks. So you'll be able to subset and look at overcrowding by day of week, time of day, the type of overload, which include wheelchair, buses, and customers, with the majority being customers, and also specifically by route. So this is looking at specifically Route 545 going between downtown Seattle and Redmond. As you can see here, alongside this route, there is overcrowding, and red color is bigger clusters of stops with overcrowding, and the yellow and green are smaller clusters. You'll be able to zoom in and take a detailed look at the overcrowding on each stop. So for the 545, as you can see here, the overcrowding on this side of the street is mostly happening in the mornings, and on that side of the street, it's mostly happening in the evenings. So if we can take that information into account in transit planning, that will be very valuable. And okay, let me toggle back. Okay, So we just looked at the 545 route. So it turns out that overcrowding has been a problem on this route, and they have already increased the number of fleets. But as we can see from our data, the increase is probably not completely sufficient in addressing the overcrowding problem. So it will be also interesting to take that data into consideration for future transit fleet planning. Another thing that we have been doing with this data is trying to use information from previous stops before the overcrowding to predict overcrowding in a stop before it happens. So eventually we will want to say that, for a bus that is coming in the future, when it gets to your stop, it's probably already overcrowded, so that you'll be able to make plans according to that. So that's something that we're working on currently. Okay, next, I'm going to pass on to Victoria to talk about our other interesting.
Okay, so one of the things that I mentioned at the beginning is one of the features of our data is this trip data, so origin-destination pairs. And this is really rich data because we can understand kind of more pattern behavior about how people are using the system, where they're originating, where they're going to. And so this application actually allows you to click on, it allows you to click on an origin and get a sense of where are the top destinations for that specific origin. So if we go down here to, say, Soto, we can click here, and this is a weekday at peak morning, and you can get a sense that red is the higher density trips, so most people are going to downtown. That makes sense. And you can toggle through a bunch of different things about to look at how ridership is different. So peak afternoon, rush hour, is actually quite different, the pattern of behavior. So a lot of people are leaving Soto and going up north rather than staying locally downtown. Another interesting thing that Alicia mentioned, so these supplemental data sets that we can bring in, you can bring in census data. For instance, so this is census data about percent minority, percent without a vehicle, and percent who are receiving food stamps. And so you compare that, you can marry that data with this geographic data about worker ridership, and then you can compare kind of how the neighborhoods are similar or different from origin to destination, which is pretty interesting. So with that, I'm going to hand it over to Shen, who's also going to talk about the trip data in a different form.
So as Victoria mentioned in the introduction, one of the features available in the ORCA data set is this field called business ID. So most businesses in the Washington state are required by law to have a commute reduction program. And most businesses in the Puget Sound region provide some form of subsidized ORCA cards to satisfy that law. And so for those of you affiliated with University of Washington, for example, your Husky card doubles as an ORCA card. And with all of your transactions, we will have the business ID of University of Washington attached to that. So here is just a basic visualization where you can select on the right-hand side different businesses. Unfortunately, due to privacy reasons, we're only able to show you hash business IDs. But imagine if you have the actual business name available here. This provides really rich information to businesses who might want to evaluate the effectiveness of their commute reduction program and try to encourage more of the employees to take public transit to work. So we'll just play around with this hypothetical business that we don't know what it is, or I can't tell you, but we can already infer some basic travel patterns. So the selections here are saying this is weekday trips during the peak morning with all types of passenger, and you can see that most number of boardings, this is just showing origin, are clustered in the Bellevue. So most employees probably live in Bellevue, assuming sort of regular commute hours. And if you click on these clusters, you can also have a pop-up that tells you for that particular boarding, the route, date, information, etc. You can also toggle between origin and destinations. So now I've switched to destinations. If I zoom back out, you can see that this particular business probably also locates in Bellevue, so most of its employees will have shorter trip duration, which is an available feature in the pop-up that you can see. So now that we've covered just 5 different apps that we built this summer, I'm going to talk to you all about the future directions of this project. So the first one is the issue of privacy. As Victoria mentioned in the introduction, there are a lot of sensitive information in the ORCA dataset. We're very conscious about the privacy issue with our data, especially fine-grained data where an individual could potentially be identified. So we've made sure to aggregate in most of our analyses at least one level up, if not more. So we're hoping that sometime this fall, the dashboard that we just demoed for you will be available live with all of those privacy protections built in, where you can go to the website and just play around with the apps that we built. The second future direction has to do with additional analyses. So the data that we've been working with this summer came from spring 2015, from roughly mid-February to mid-April. So if we have more recent data, we would be able to do a lot of interesting comparisons and additional analyses using the methods that we developed this summer. For example, both the Capitol Hill and the University District link stations were open after the time period of our data set. So if we have more recent data, we can compare how the openings of those stations changes travel behavior and patterns. There's also the ORCA Lift program, which is the subsidized program to provide ORCA cards to low-income residents of Puget Sound. That program had just begun sort of smack in the middle of the time period that our data set covers. So if we have more recent data, we can, if you were able to go and play around with the first descriptive app we have right now, you can see the ORCA Lift usage, the low income usage gradually increasing, and it would be really interesting to see what sort of changes that had occurred after that. And the third future direction is with the dashboard that we built, ideally we'd hope that it would be useful to local transit agencies, especially if they can adapt it to link it to a real-time database. So that could help with immediate responses to things like overloading and vehicle issues, for example. Finally, we hope that everything that we did this summer will be very useful because we believe that it serves as a foundation of sort of smart city approach to transit planning in the Puget Sound region. So we're really hoping that these analyses would not just stay here, but also be widely used outside of this program. So with that, I'd like to thank all the organizations that made this project possible, especially the eScience Institute for hosting us this summer, and to the ORCA board for allowing us access to the data. And at this time, we'd like to take any questions you may have. Thank you.
Hey, I got a couple of questions. One of the data that you guys got, did you get access to the ORCA card's balance?
No.
Okay, no balance.
No financial information of any kind.
Then did you get access to situations where they tried to tap and it rejected because there was insufficient balance?
No financial data of any sort.
Okay, gotcha. So how much? What was the sort of the length of time, but how much data do you have exactly? A few months or a year?
9
weeks.
Yeah.
And about 20,
Almost 30,000.
27.
Over 27 million taps in the database.
21 million.
Okay.
21 million.
And if you were to go to a more short-term model or real-time, as you mentioned, how much time do you think, like how many rides does it take before you start getting meaningful data? Like you can't just look at like 10 minutes worth of data, you're just going to get noise. Like, do you need to look at the last 3 days or a week or whatever before you start getting meaningful patterns?
So there are papers that looked at a week of data.
Yeah, so in our sort of initial research, we found that most people who are doing academic research on transit behavior, people have started to look at fare card data, but usually at a much smaller scale. So like one of the most cited papers only looked at 1 week's worth of data, and we're doing 9 weeks. So in some ways, we're not reinventing the wheel exactly, but we're sort of expanding on a much larger scale. In terms of the real-time response issue, I think there are certain analyses in the suite of apps that we build where, like for overcrowding, for example, that one will be much more easily integrated into a real-time feet because when an overcrowding occurs, it will pop up, and then the transit agency can immediately work to address that. Whereas some of the more sort of macro pattern stuff, that is probably not most useful for real-time stuff, but it will still be very useful for future planning, for example.
And did you have to work with, or did you get to work with SDOT at all or any of the transit agencies on this, or are they going to see this and be like, why didn't we build this 2 years ago?
So, I guess in a short answer, sort of. So our project lead, Mark, has relationship with lots of transit agencies locally, and you know, there's lots of presentations, you know, trying to convince transit agencies that this data is useful and should be used for future planning. And of course, we recognize that many people in local transit agencies do know that these data are useful, but there are budget constraints or staffing constraints. So we're really hoping that by doing the work that we did this summer, we did all the challenging part with the data processing, and they can take the products and then run with it, essentially.
Thanks.
Oh, so many questions. Green shirt had a question earlier.
I have a couple too, actually. So the first one is, so you have ORCA card readers that are moving on buses, and you have ORCA card readers that are stationary for the rapid ride and for link. How does the data deal with that?
It doesn't. It doesn't. Basically, we, if you want to be totally honest about it, if you're looking at the because you don't know what route someone boards. If they tap to get on a rapid ride, you don't know, is it the A, B, C, D, or what? So in a sense, any data we have about a route-specific rapid ride is biased towards people who like to tap on the bus rather than on a pillar. But we do still have all the taps that were on a stationary post. They're just all grouped together. So you can talk about who rides the rapid ride and each of the locations of those posts, but you don't know specifically the route information about that. If you're working in the origin destination files that we didn't talk about in detail how they're constructed, you could probably sort of interpolate which route they're on if they're always getting on downtown and then getting off at the end of the C, for example.
And then my other question was, did you try looking at maybe the on-time performance of buses with regarding to the overcrowding?
No, we haven't looked at that.
Not had the chance.
Yeah, we need to merge that with GTFS data, and that's certainly possible.
We do for some, because we get data from all the different agencies, we get different amounts of data, but we could start that analysis if we wanted to, but there's so much you can do with this data.
I know.
We should probably emphasize that the 5 apps that we showed were all built in basically like the last 2 weeks, a week and a half.
Because of the data cleaning, which took all summer.
So this is just scratching the surface of the kind of rich analyses that you can do with the data.
I was wondering how the duration is measured when you're on routes that require tap off.
Yeah, so that has to do with the origin destination pairs. So there's the algorithm that it goes through is basically if you tap on a bus, say I get on in Ballard at like 9 a.m. and then you don't know when I get off, but I tap on in the U district at 4 p.m. And because the 44 runs along that, we can estimate, we can assign where I got off, probably when I got off, given that I was taking the 44 in the morning. And so for about half of the 21 million, not including the transfers, we have about half of those pairs. Those are actual pairs. And so then you can actually get a duration by using the vehicle location. Yeah.
How more geographically specific can you get before you start to make people concerned about privacy? Could you go into the bus route level and just do visualize things along a single transit line, for example, or where do you start to make people concerned?
Yeah, I mean, I think that you. Right, there's such fine grain. Yeah, I think any form of aggregation one up makes people feel very comfortable. I think that people start to feel uncomfortable if they can find themselves in the data. But if they can just kind of broadly see patterns, that is a lot more reassuring. So in all of our analyses, we tried to stay one level up so that
At the very least,
so that we're kind of capturing the richness of the data, but not creeping ourselves out while we are looking at
So it
it.
sounds like you would never visualize below what you've already shown geographically, is that right?
I mean, we played with visualizations a lot aggregated to route. Right now, for some of the analysis we were interested in doing, we were looking at census tract level because that a lot of what we've been interested in has involved also taking into account census tract information. So because one of the big questions is how does the patterns of ridership, how does that sort of correspond to sociodemographic patterning around the region? But internally, we've done plenty of analysis sort of looking at sort of behavior along the route. And I mean, we haven't done any testing with the public about this. You guys are the first people outside of our group to see any of this data. So we don't actually know when people start to go, whoa. But I would imagine that sort of route level aggregation or looking at, boardings at stops, as long as you, like Victoria said, it's like when you're like, oh, I can see there I was and there I was here, and you can like feel like someone else could find you, that's uncomfortable. But when you're like, when you can just see your own journey, maybe not. But no, this is something that we would be really interested in sort of talking about more, because we, as a group, I think we're really committed to trying to make as much as we've done public that we can, responsibly, but also a really sensitive fact that right now we couldn't, putting aside the database security side of the data analysis, we wouldn't even be willing to just throw this up on the internet as it is now as an interface without thinking through some of these issues a lot more closely.
Sure. Yeah, go.
So first of all, I want to say on behalf of the Sound Transit Research Program and the ORCA system, this is really outstanding. This is impressive stuff. And second question, I know you've only been able to get into some of the data analysis over the past couple of weeks, but have you looked at any sort of trend analysis, so rather than looking at the data as a snapshot and doing descriptive visualizations, looking for trends and patterns in the data over time that could give us more business intelligence about when something is maybe about to be a concern?
It's a biggie.
Yeah, so we played around a lot with descriptives. So there's many different routes in this database. That's why we come up with this Shiny app to visualize, like when you can go into specific routes and look at the counts and stuff like that. Specifically for overcrowding, we are currently in the process of predicting overcrowding in the future. So if that can be based on a live database, then we can potentially predict an overcrowding one stop before it happens. Then, or just visualize it as it happens so that we can add more fleets to address that.
I mean, another thing that we had sort of wanted to do at the very beginning was initially we were going to have a second set of data in spring 2016, but various issues made that impossible. So if we had that, one of our initial ideas was we could compare the changes between 2015 and 2016. And based on the research that we did with sort of academic papers on transit, those kind of time series would allow you to do more of the predictive modeling stuff that would be helpful to business intelligence stuff. So we thought about it, but
on to sing our own praises a little bit more though, we haven't totally neglected the kind of dynamic element of the data. And a lot of what we've done, we have paid attention to time of day. I mean, even just the descriptives up here right now is partly seeing, you can look across different routes and when you zoom in, you can see how different ridership groups are targeting their own trips at different times of the day, which is really interesting. And I mean, one of the points that I think Victoria made in her introduction was like, you can actually see how it was either Victoria or Sean, the ORCA lift, you can see the uptake of ORCA lift as you go through the database, which is really interesting. Like if we were zooming in the time frame, moving the clock forward, just on the descriptives, you can see as people start to take up the low income cards.
I see a date range.
Yeah, so you can
there is, but I think that its connection back to R has gotten a bit frozen, which was an issue we were having just before we came down here. So rather than break it, I just decided. Yeah, and this is actually what I started to try and play with earlier to pull it down to a week of data, but it didn't update. So I think I might need to refresh the app. Oh, is there just a miss? Oh, there's a missing dash that as well. I was trying to listen to my colleagues while entering.
There we go.
Okay, yeah, so there we see that drop. So yeah, we can, pull the date range as we want, but I don't want to take a lot of time from the other presentations by
I just want to say I look
demoing.
forward to having you give a presentation to the planning folks and our IT folks and our executives?
We've heard rumors that that might be in our future.
Come to watch that.
Okay, here we go. Thank you.